Meters connection, Modbus RTU, serial. In this video, we will demonstrate how to connect the ePowerControl to the meters using a serial connection. This video is divided into 6 sections. Required materials, meter configuration, connecting the meter to the controller, configuring the LAN port, adding the meter to eConf, testing communication with the meter. Part 1. Required materials. Alum's device and the meter are communicating in Modbus RTU. For this, we will need Alum's device, a switch required for multiple device connections or for wired internet connection. DB9 connector terminal block. Shielded twisted pair cable. Termination resistors with impedance matching the communication cable, typically 120 ohms. Flathead screwdriver. Bootlace ferrules. Laptop. RJ45 to RJ45 Ethernet cable for configuration purposes. USB to RJ45 adapter if your laptop does not have a LAN port. Wire stripper. Crimping tool. Part 2. Meter configuration. Before connecting the meter, let's review a few essential items you'll need to. Start by selecting the system type for your site. Set CT and VT ratios using the shown formula. Make sure the measurement type allows both positive and negative readings. For Modbus, assign a unique slave ID and set the baud rate, parity, and stop byte according to the device manual. The baud rate, parity, and stop byte can be found in the device manual. Part 3. Connecting the meter to the controller. Grab the twisted pair cable and identify the color code based on the manufacturer's manual. In our case, we will use the brown wire for data B positive, the white wire for data B negative, the yellow wire for ground. Try to organize the wires for better handling. Use the wire stripper to remove the insulation from the wires. It is recommended to use bootlace ferrules, as they provide a more reliable and secure connection by preventing fraying and ensuring proper contact. Make sure to securely attach bootlace ferrules to each wire. Grab the terminal block and start by putting the ground wire, yellow, in pin 5. Grab the terminal resistor and place it between pin 3 and pin 4. The brown wire, positive, must be connected to pin 3 data B positive, and the white wire, negative, to pin 4 data B negative. After properly connecting all the cables, reconnect the terminal block to Alum's device by plugging it into COM1. Make sure to securely tighten the ends of the terminal block to connect multiple devices to the same serial port. Follow the steps and diagrams shown below. Note that some devices may not have ground ports. In such cases, only connect the data pins as described. It is highly recommended to use surge protection to prevent issues with the communication ports. Part 4. Configuring the LAN port. Connect your laptop to the LAN port 4 of Alum's device. When properly connected, the LED should start blinking, indicating a valid connection. Access the settings from your laptop. Go to Network and Internet Settings. Go to Change Adapter Settings. Right-click on Connection to the local network. Select Properties. Click on Internet Protocol version 4, TCP/IPv4. Select Properties. Select Obtain an IP address automatically to enable automatic IP address allocation. Or select Use the following IP address for manual IP address assignment and enter the settings as shown in the next window. A small TCP/IP window will appear. Click on Yes. Then click on OK to save configuration. Open your preferred browser and log into eConf by entering the following IP address: 192.168.4.127. Enter your password to log into eConf and click Sign In to connect. On the left sidebar, click on Network. Click on Configure a new connection. Then in the interface menu, choose Serial 1. In this list, select the serial where you physically connected the meter. Select the appropriate operational network communication mode. Select the appropriate baud rate, parity, and byte size, which must be identical to the one set on the meter. Select the appropriate stop bytes. Click on OK to save the settings. Part 5. Adding the meter to eConf. In the column specific to the Serial 1 connection, click on Add Device. Enter the device name. Select the meter's vendor from the drop-down list. Select the reference of the meter from the vendor-specific drop-down list. Select the Modbus RTU protocol for communication between ELM's device and the meter. Select the meter's role from the drop-down list. Enter the slave ID assigned to the meter. Configure the response timeout and byte timeout. The interframe delay is set to 10 by default. Click on OK to save the settings. Part 6. Testing the communication with the meter. To test the connection between ELM's device and the meter, first check the communication status by clicking on the three dots next to the name of the meter you added. Click on Test. If your meter is not connected, this window will appear with the red indicator. Follow the provided troubleshooting instructions to help resolve the communication issues. Another way to test all devices connected to the same port in a daisy chain is by clicking the refresh icon next to the configured port Serial 1. This will display the status of those devices, and you can expand the window by clicking on the device name. eConf provides a few troubleshooting instructions to help resolve communication issues. Once all these steps are completed, communication should be established. As a second step of connection testing, let's verify the data acquisition. Navigate to All Devices from the left sidebar. Click on the recently added meter. The page displays all the data that the controller will read from the meter. Cross-check all the read values with those displayed on the meter itself. If applicable, the controller must receive accurate data to prevent issues in control scenarios and set points. Let's go over some common issues that may come up. If power meter values seem off, check that the VT and CT ratios are set correctly as shown in Section 2. If only the cos phi is incorrect, it's likely due to CT or VT wiring. Rearrange them, making sure the phases are correctly aligned. If values have incorrect signs, ensure negative power monitoring is enabled. The meter is set to bidirectional, and the CTs are installed in the correct current direction. Please feel free to contact ELM support or your sales managers. Eager to see you in our next training session.